The next part of the process, we're going to design the jack shaft. So you may or may not know what a jack shaft is. It's very commonly used. So it's a mechanical device. It's used as an intermediate shaft. It's going to transmit power from the motor to the rear wheel. And there are several advantages here. So you can see in this diagram, here's the chain that comes off the motor. This is the jack shaft. So there's a sprocket there that the motor will drive. Then there's a sprocket on the other side that will drive the wheel. So a couple things it'll do, help to align the chain with the drive sprocket. It also allows the rear wheel to pivot without causing the chain to become loose or tight as the suspension cycles. It also allows you to change the gear ratio. So for example, these two sprockets are the same in this photo, but you could change the size of the sprockets here, and then you can change the overall gear ratio. Here's an example of a simple frame. It's a mini bike with a small gas engine. So this system here, now here they're going to drive the driven sprocket is on the same side as the motor drive side. We're going to switch sides, but here's your jack shaft. So it's got bearings that it rides on. This shaft has a key in it, and the sprockets are key to that. So when one sprocket turns, the other turns. So your chain would drive, in this case, the chain is going to drive this sprocket, and then this sprocket is going to drive the rear wheel. And that's primarily for alignment cases here, but also suspension travel. You want to have this pivot as close to the swing arm pivot as you can. Otherwise, as the suspension moves, for example, as the swing arm moves up, the chain would get would get loose and it would fall off. And if the swing arm would go down this way, the chain would get tight, so tight that it might even break. Okay, so this shaft transmits power. Then there's a second shaft for this design, and the swing arm is mounted to that shaft, and that's mounted on bushings. And so the swing arm can pivot up and down along with the drive system here. And the closer you get these two centers, the better off you are for maintaining the tension on your chain. Here's a side view. It's a very simple design. I kind of like this design. So here you can see this is the jack shaft. Now in this case, the motor drive is on the opposite side. The wheel drive is on this side. So we're going to change power from the left side of the shaft to the right side by going through the jack shaft. Again, there's a bearing mounted on each side of that plate with the shaft inside. Here, now that's a bolt, that there's a shaft that's mounted to that bolt, and that's where the swing arm pivot goes, right there. This is the other side. You can see the drive chain coming from the motor. There's the bearing for the jack shaft, and there's that pivot point for your swing arm. Same picture without, as before, without all the arrows on it. And here's another design. It's very similar. It doesn't have the motor on, so maybe you can see a little bit more. In this case, again, the motor would drive this sprocket, which would drive that sprocket, which is going to drive the rear wheel. And you can see there's two different size sprockets there to affect the gear ratio. This is an interesting unit. It's for some sort of a motorcycle that has the jack shaft is built into the swing arm. So that's the same kind of concept as one of your options in terms of designing this jack shaft. So I'm going to show you two different types that I've identified. There's other ways to do it. I think these are probably good, simple ways to do it. This is the method that we've seen before. It has the two shafts. So this shaft, the swing arm is going to pivot on that shaft. It's mounted on bushings. So you can just use bronze bushings because you're not seeing 360-degree rotation or high revolutions. So that'll allow the suspension to move up and down easily on the shaft right there. And then here's my jack shaft with the two sprockets on it, and that shaft's mounted to a bearing. And we're going to need to design this unit. In this case, I have a dummy piece of tubing in there because I wanted to make sure that my swing arm wasn't going to interfere with these side plates. So this type you can identify because it has two shafts as part of the unit. Here's the jack shaft unit without the swing arm attached. So your swing arm, that's the pivot tube. Your legs for the swing arm are going to attach there. And here it is exploded, so you can see all the pieces. So it's really pretty simple. You can buy some commercially available bearings, and these are just little bushings that you can buy or design, and that's all the parts that you need for that. Now here's a second type I've seen, and this type uses one shaft. So there's an inner shaft there. It has keyways cut on it, and these sprockets will be keyed to that shaft. So again, the motor would drive this one. It would drive the inner shaft, rotate that sprocket. Now our driven sprocket is on the other side of the wheel, so then the chain will go to there and drive the wheel. The chain will loop over the swing arm and then under. Here now, inside of this tube, and that's part of the swing arm, there are some needle bearings, and that will allow while the shaft is rotating, it will allow the swing arm also to pivot up and down. That's what makes this really work. Is those, the shaft that's rotating is mounted to bearings, and then this pivot tube, I call it, on the swing arm is mounted on the inside of that. It's got needle bearings that let it rotate on the shaft. So a lot of action happening with that shaft. Here's the unit without all the other stuff on it, so you can see it's relatively compact. Here's the exploded view. There's the inner keyed shaft. There's the needle bearings that fit inside here. So there's one on each side. There's a couple of bronze bushings to prevent steel on steel wear. There's a bearing, and then I've got set collars on the end that you lock on the shaft, and that'll keep the whole unit from coming apart. There's not really any axial load, but just from vibration or so forth, it would keep the bearings from falling. And just to review, needle bearing looks like this, so the shaft would fit inside of that, and then that would fit inside of another. Like in our case, it'll fit inside the tube, and it's very compact, and it's good for the kind of loads that we have and the speed that we have. And there's a flange ball bearing, so little ball bearings in there, but it's sealed, and it has a flange, so when you press it into the side plates, it won't come out. And there's a flange bronze bushing, which you can buy or you can make, and just a bronze spacer. It's kind of like a washer that you can use on this shaft. Again, you don't want steel on steel friction, so that bronze is going to prevent that. It will allow easy movement between the parts. So in terms of processes, and this is how I did it, I first of all obviously decide what kind of jack shaft you want to use. You may want to do a little research on that. And then look at the overall width of your swing arm. So you've got an assembly with the swing arm and the rear wheel and everything on it. Look how wide that is. We want to try to maintain that width for the jack shaft assembly, because that's approximately how wide your frame is going to be. It's really important that you're able to align the sprockets. So the sprocket on the jack shaft that's going to drive the sprocket on your wheel needs to be able to be aligned there. So what I did was add a work plane onto the assembly, so I knew exactly where the face of that sprocket was. So I made sure that that would line up, and it may require you to modify your swing arm a little bit, but shouldn't be significant. So then I created a new assembly. So I inserted that swing arm sub-assembly model, so just the tubing model of the swing arm, and then I kind of developed my models, designed to model them, and then I inserted them into the model, and then I designed them as I go and build it until everything fit together. And so it meant I had to go back to my models and revise until I got all the parts to fit together. So I just wanted to show you again what I was talking about. So I just made a work plane on the face of that sprocket. So now I know when I build my jack shaft assembly, that sprocket that goes right there has to align with that. So what I realized was I have to modify, these tubes were too wide, so I had to reduce the width of that tube. It's not a big deal. Just go into that part, change the length of it, and update your part. So keep that in mind, because kind of the whole purpose of this is that we would be able to drive this, so the sprocket has to line up. Just a few notes. Keep in mind that the jack shaft unit's got to fit on the frame. That's the next thing we're going to do, is design the frame. So it's pretty likely we're going to have to make some edits to the jack shaft, but at least we'll have the basic design down. Let's see, obviously you're going to have to revise parts as we go. That's just part of the process. And whenever you're putting, like, if you're going to allow space for a bearing or something, make sure that it's commercially available. So look at a manufacturer's catalog, find the ID, OD, width of the bearing, and then build that into your design. In fact, if they're available, you can grab those models and just put them into your assemblies. That's totally okay. Same with like sprockets. Make sure the sprockets you're going to use are something that's actually available. Now those side plates, those are just kind of ballparking what we're going to have to do once we have our frame. So it's highly likely we'll have to revise those side plates so they fit better to our frame. That's just going to be part of the process here.